Imagine a client has hired you for programming a video game, and one of the core features of this game is all of the playable characters are ducks. Every character is balanced because they have similar movement and physics, but each of them have their two unique abilities, which are the way they fly and quack. The question is, how do we write code for this game? And if you're watching this video, I'm assuming that you already know something about object-oriented programming and some of the basic techniques, so we won't dive into that here. Let's get started with our code. The simplest approach would be to create a duck base class with common functions in it, and then inheriting this base class to create specific ducks and implement their unique abilities there. The catch is we have a lot of ducks to create, and the client already has a list of hundreds of ducks that need to be added to the game. There is also a possibility that some of these ducks can be very similar to each other while others can be completely different. And it is also possible that one of the unique abilities may not be even applicable for some types of duck. And as always, for every software, the requirements are going to change with time, so we need our code to be highly flexible and maintainable. Now we can still stick to our original plan of base class with common functions and a bunch of derived classes containing unique abilities. But whenever a new change comes that affects all of the wooden ducks, for example, we will be making changes to a significant number of derived classes, which might not be fun for all of us. Here we are breaking the basic rules of software engineering, which are don't repeat yourself and don't make things harder to change. Let's look at how the strategy pattern can help us in this situation. The basic idea of strategy pattern is to separate the things that stay the same from the things that can vary. For example, in our duck, the movement and display function is same, but different ducks have their unique flying and quacking behavior. We can create interfaces for fly behavior and quack behavior. Now, for each duck, we can create concrete abilities by implementing these interfaces. For example, for the first two ducks, these were their unique behaviors. In our base class, we can add references to objects of type fly behavior and quack behavior, basically doing a composition, which is also known as has a relationship between objects. Here I've also added setter functions for fly and quack behavior. This is just to make things convenient, but these can also be initialized in the constructor. The overall class diagram looks something like this. We have successfully separated the things that change, and the common functions are still in the base class. Let's run through some examples to understand how this code works. For the first duck, it has a flying behavior of fly up to 2 feet and quacking behavior of not loud. First, we derive a class from the base class duck. Second, we create unique abilities by implementing the fly behavior and quack behavior interfaces. And then we set these abilities to our duck using the setter functions. Similarly, for the next duck, if we have a new ability, we can implement that and then set it to our derived duck class. And in the same way, we can create rest of the ducks. But now the client wants all of the wooden ducks to start flying up to outer space, which was not the case that was programmed initially. But luckily, we do have a common flying behavior assigned to all of the wooden ducks. So now we simply need to change the wood fly behavior and implement the outer space flying logic in it. And we didn't have to make changes to all of the wooden duck classes one by one. These changes will be reflected in the game whenever the game startup routine re-initializes these ducks. The point is, by implementing the strategy pattern, we minimize the number of changes required to be done in the derived classes, and now we are only making changes to the behavior classes, whereas the derived classes remain as they were. To summarize how to remember using this pattern in our everyday coding life, there are 3 key points to notice. Identify the aspects that vary and separate them from what stays the same. The second one is to program to an interface instead of an implementation, or also known as concrete classes. And the third point is favor composition over inheritance because it offers more flexibility to our code. For more programming videos like these, hit the like button and destroy that subscribe button.